Okay, guys, we're going to start by going over the homework, or the classwork, which I assigned during class today. We probably already went over some of these in class, but I just wanted to make sure everybody had all the right answers to this review assignment. So we'll start with what is an observations? It is a statement. Sorry, I should have added that you use your five senses for. An example of this is the classroom is cold. So you use your sense of touch or your feelings to feel that it is cold in here. What do you need in order to make an observation? You need to use your five senses. Answer the following question using a complete sentence. When you're using an instrument to measure something, are you still making an observation? Yes, an instrument is a tool that extends your five senses. Again, if I already said the classroom is cold, the instrument that I would use to help me with that would be a thermometer. And now instead of just saying the room is cold, I can say the room is 58 degrees. So that's still an observation. It's just I made a better observation using an instrument. So what's an inference? It's a guess based on your observations. And what do you need to make it? Again, an observation. Are inferences always correct? No, they do not have to be correct. You could guess wrong. So a good inference, if the room is cold, I could guess that the heater's broken. That could be one guess. Another guess could be if the room is cold, the air conditioning is blasting. Those are both good guesses, but I'm not sure which one's right. And again, they're both good inferences, but they're not both right. Moving on. So using a complete sentence to find prediction using the word inference. So prediction is, you can see I started with a guess, but I had to use the word inference. So prediction is a guess, which is an inference about the future. So a prediction is an inference. It's just a specific one about the future. Now we have to describe what it means to be cyclic. It's an event that happens in a repeating pattern. Non-cyclic, an event that does not happen in a repeating pattern. Which type of event? Cyclic is easier to predict. There's lots of other examples. So other than an earthquake, give me a non-cyclic. I went ahead and said hurricane. Again, they happen. Yes, there is a hurricane season, but it doesn't happen in a repeating pattern. I can't say in June 2034, there's going to be a hurricane. Other than moon phases, give me an example of a cyclic event. Again, there's lots of them, but tides is a really good example. You don't need that one. All right, so hopefully during class you went through all of these. I'll just go through them real quick. So if something was transported by a glacier 1,000,000 years ago, that's just a guess. We weren't there to watch it happen, so it's an inference. If we have a sample that's rectangular with sharp angular corners, that's an observation because you can plain old see that. The water will become unsafe within 5 years. That's a prediction because it's a guess about the future. Number 4, some of the snow on the glacier is powdery. That's an observation because you can see it. Sample is 8 centimeters long, 5 centimeters wide, and 3 centimeters high. That is still an observation, but yes, you used an instrument to make your observations. Number 6, hot and humid conditions will continue throughout the week. That's a prediction. It's a guess about the future. There are many cracks in the glacier. That is still an observation because you can see it. Same with the sample is white in color. That's an observation again because you can see it. A meteor impact caused the extinction of the dinosaurs. That is an inference. It's a guess. We weren't there, we didn't see it, and it's not about the future. So that is inference. The rocks in the glacier are different sizes. That's an observation because you can see it. You don't have to guess. Number 11 is a little confusing because it's a little longer, but it says the rock is spherical. That part's an observation, but if you keep going, and must have been transported by a stream, that's a guess based on the fact that it was spherical. And finally, question 12, some parts of the glacier will start melting this spring. That is a prediction because it's a guess about the future. All right, going on to density. Looks like I forgot the first one. Density is defined as how tightly packed a material is. So just how much stuff is jammed into a certain amount of space. I like to think of that as how tightly packed you pack your suitcase. So you can either really densely pack it by shoving everything you own in it, or just bring a couple of outfits. The formula is density equals mass. I should write that out. Mass divided by volume. And the key is with density, size does not matter. So if you cut it in half, the density will stay the same. If you cut it in 8 pieces, the density will stay the same. If the density starts off at 1 and we cut it in half, it'll still have a density of 1. If the density is 25 grams per centimeters cube and you add twice as much, it will still be 25 grams per cubic centimeter. Most objects are more dense as a solid except for water. Water is the most dense as a liquid. Remember, ice floats in water, so the ice is less dense than the water. This is right off your reference table, the density of water. Oops, ripped in my reference table. Density of water at 3.98 degrees Celsius is 1 gram per centimeter cubed. So that fills in number 9. Density does change with temperature and pressure. So as temperature increases, density goes down. Again, think of a hot air balloon. You're heating up the air and then the hot air balloon floats. So its density must go down. Temperature on the X, density on the Y, and a going down line. Now remember, so if we have a low temperature, we like something that's really cold, we have a high density. A hot temperature, like a hot air balloon, a very low density. That's why it floats. The opposite is true with pressure. As you put and squeeze something, as you put more pressure on something, the density increases. So pressure on the X, density on the Y, low pressure, low density, high pressure, high density. Just did my work here. Remember to always read the directions. If it says round to the nearest 10th, you have to round to the nearest 10th. So mass divided by volume, 10 divided by 15 gives you this long number, but it said to round it to the 10ths. So that's 0.7 grams per milliliter. This one I had, now it asks, what is the mass? So you could do regular algebra or always use the magic triangle. So remember, M goes on top because it's most important, and then these two don't matter. But if you're looking for the M, you cover that one up and we get D next to V, which means to multiply. So 3 times 30 gives you 90, but again, it said round to the nearest 10th. So that's 90.0 grams. The milliliters cancel out and you're left with just grams. How do you figure out the mass? Well, you put it on a scale. How do you determine volume? Well, you can do length times width times height, or you drop it into a graduated cylinder and see how much the water goes up. And then you do density by doing the formula. Density equals mass over volume. Just a couple repeats here. What do you need in order to make an observation? Your 5 senses. What do you use when classifying objects? So remember, that means to put them in groups. You use observations. A prediction is an inference, which is just a guess about the future. A measurement is an observation or an inference or prediction. Remember, a measurement uses an instrument to extend the 5 senses to make an observation. If a person observes a sediment consisting of clay, sand, or silt, that makes that an observation. If they then guess it was transported by and deposited by an agent of erosion, that's an inference. And then if they put them together, they see sediments consisting of sand, silt, and clay, and they said that material was transported by an agent of erosion. That whole statement is an inference. They see an observation and they make a guess. A cyclic event is predictable, a non-cyclic event is unpredictable. Moon phases are cyclic, which make them predictable. Ocean tides are cyclic and predictable. A meteor is non-cyclic, which makes it unpredictable. Sunrise is cyclic, which makes it predictable. Earthquakes are which makes it unpredictable. Again, straight off the reference table, what is the density of water? Oh, sorry, what temperature is density of water the greatest? That's on the first page. It's 3.98 degrees Celsius. How can you tell if a substance is made out of the same material? It'll have the same density. What's the formula? D equals M over V. If you heat an object, its density goes down. And if a rock floats, then the rock is less dense than the water. Again, we're going to plug in for the magic triangle formula. M always goes on top because it's most important. Or in case you forget, we know the formula for density is mass divided by volume. So there we have mass on top of volume, which means mass divided by volume. When you use the magic triangle, you cover up the one you're looking for. So volume equals mass divided by density. Mass equals density times volume. I labeled these over here. If you switched these labels, that's okay. So if we have A on the bottom and B on the top, that means B is less dense. And how do I know B is less dense? Because it's floating on A. Plugged in my math here, density equals mass divided by volume. So if I have a mass of 24, a volume of 6, my density equals 4. What happens if I cut it in half? What happens to the mass? Well, half of 24 is 12. Half of 6 is 3. Plug in the formula 12 divided by 3. That gives you 4. This one required a little bit of reading. An empty 100 milliliter graduated cylinder has a mass of 145 grams. When 50 milliliters of a liquid is added to the graduated cylinder, the total mass is 195. So the volume is how much liquid there is. They told you 50 milliliters. Now the mass, we had to do a little bit of work. We started off at 190 or 145. And then when you added it, it weighed 195. So you have to subtract those two and you get 50 grams. So plug that in, 50 divided by 50 gives you 1. Should have probably labeled that 1 gram per milliliter. What this liquid is probably water because a density of 1 is always water. To figure these out, you just read the formula, mass divided by volume. So if you can pick anywhere, I picked some nice easy spots. If I have a mass of 30, go over till it hits the line. Actually, I went from 30. I did 20. So 20 divided by 2 gives me 2. I could have done 30 divided by 2.5 would have worked as well. But 20 divided by 2 is easier math. That's 10. For Y, I went from 30 and 6 gives me a density of 5. And for Z, I went 10 divided by 10 gives me 1. Again, you could have picked anywhere on there and still gotten the same answers. It just wouldn't have been as easy of math. All right, that was the review of chapter 1. Hopefully some of that sounds familiar and you're able to go on to chapter 2 tomorrow.